Okay, so with this one, the first thing that students make, the mistake that they make is they apply a log law, but they have this constant 2 out the front and they have this constant 2 out the front. Don't make that mistake, please, when it comes to your assessment, because it's the most common mistake. So what we need to do is we need to apply law 3 first, and let's write out our next line. Our next line is log to the base 10, bring that 2 inside, which means... I don't want snipping tool. Don't know how the hell that happened. 3 to the power of 2. Let's keep going. Plus log 10 to the power of 4. And then we've got minus. Now, I'm going to leave the negative out the front. I don't have to, but I am going to do it for the time being. All right? So there are 2 methods of doing this. Log 10, that 2 comes inside there, so it's got 6 over 5 to the power of 2. I hope you're following me so far when it comes to that law. Now what we need to do is we've got log 10 of 3 squared is 9, plus log 10 of 4, minus log 10 of 6 squared on 5 is 36 on 25. Now what we have to ask ourselves is the coefficients of each of these. 1, yes it is. Now I can apply the log laws, law 1 and law 2. We can apply it in 2 separate situations though. I can collect these and apply that law once if that makes sense. I can say that that is equivalent to log 10 of 36. 9 times 4 is 36. Now I've got that is equal, so that's equivalent to, this line here is equivalent to log 10 of 36 minus log 10 of 36 on 25. You might have had a different method, but I'm just showing you my method. Doesn't mean it's the method you have to use, but I'm generally try to show you the fastest method. Now what we do is we apply law 2. Law 2 states when I've got 2 logs of the same base, then what we do is we divide the index, if you like. So what are we doing? We're getting these 2 things and we're dividing them. Still to the same base though. So what does that mean? It means we've got 36 over 36 over 25. Now you can go ahead and do that, but I guess I want you to realise that if I've got a whole number divided by a single fraction, then that's not simplified. I can get this 25 and effectively throw it up here. Times, so rather than divide by 25, it's like timesing by 1 on 25. So what we can get is these 36s are going to cancel out, and we're left with log to the base 10 of 25. Can I get a show of hands, the students that got that correct? Well, show of hands. So I'm assuming that less than half the class got that correct, because I'm only seeing 7 hands. No, the log 10 of 25. 10 to the power of something is 25. We can show you later. All right, the next one. First of all, there is no such number that 4 can be multiplied by itself by to get 8. So the magical number is not 4 anymore. It is what number? 2. Thank you, Eloise. So let's do that in brackets. 2 squared on the left-hand side to the power of 2x plus 1. I'm going to go through this pretty quick. Is 2 cubed, 1 minus x. That's the first step you do. Now what we do is we apply our index laws. 2 times 2x plus 1. Be careful because we're expanding that out. We've got two terms. 2 to the power of 2x times 2 is 4x plus 2. And on the right-hand side is 3 minus 3x. Now, because I've got the same base, I don't have to go do anything crazy. You can't just cancel these out effectively, but because they are to the same power, yes, I guess you can say that what their powers are equal because it's the same base. So we've got 4x plus 2 is equal to 3 minus 3x. I'm going to add 3x to both sides, which gives me 7x is equal to, and we're going to subtract 2 from both sides, which is going to give me 1. x is equal to 1 over 7. Can I get a show of hands of students that got that correct? All right, if you didn't get up to that in the time given, you need to revise before your test because you might be under some strict time issues if you are not getting that done in the time.
B.
Yes, we're doing B. Yes, okay, we're going to do B now. All right. So, for B, log to the base of x. Now, first of all, 1/9. What do we do here? Okay, I heard someone say that that's 3 to the power of minus 2. Is that correct? Is equal to negative 2. Okay, now, what can I do to... Now, I could do a few things, but what is the inverse? What is an inverse of log x? What is the inverse of log x? Can someone please put their hand up and tell me? What is the inverse of log x? Throw it with you quickly. All right, so the inverse of log of x, is, if you like, x to the power of something is the inverse of log of x. That's the whole point of logarithms. Now, what I was saying to you is, for example, if I had 2 to the power of x is equal to 7, then if I was solving that equation for x, I can do log to the base of 2 to the power of x, and that what I'm saying to you is that they cancel each other out and my left-hand side is x. And then if I do the same thing to the right-hand side, we could say that x is equal to log to the base 2 of 7. Now, that's why we have logarithms. And I know that sometimes at the moment, for some of you, that's out of your, it's just, some of you aren't quite getting that, which is okay. But in this instance, this is a Year 11 methods question, okay? So give it some time, all right? X to the power of log x. If I'm going to do x to the power of the left-hand side of 3 to the minus 2, okay? And let's do the same to the right-hand side. X to the power of minus 2. Now let's see what happens. Yes, they do. And what we have on the left-hand side is 3 to the power of minus 2 is equal to x to the power of minus 2. Can someone tell me what x is then? Thank you. X is equal to 3. Now, you could have solved this another method, but I'm just showing you my method. It's actually not that bad when you think about it. But in order to solve this, a lot of you are using shortcuts, like, for example, log to the base of 3 of something is equal to 81. Then if I just said this something was x, what is x? What is x? 3 to the power of something is 81. 4. Now, you know how to do that. But the problem is that when it comes to solving equations with logarithms, a lot of you don't know how to apply the pure mathematics when it comes to that. And if you don't understand that, that's fine, but I've just shown you the whole purpose of logs to begin with. They're to solve equations, exponential equations, by using the inverse. Okay? Now, I'm going to give you just a couple more, and then we're done for the day. There you go, away you go. Have a go at this one, please. This is from a year 11 methods test. Oh, sorry, my apologies. 8 to the power of 3x minus 1. There you go. Have a go at this. And if you're watching this video at home, pause it and have a go. Okay. All right. So, the hint with this is these two numbers here. The 8, the 16. Well, it's not really going to help you out too much. What's that? Yes, it's recording. Okay, so the hint with this question is our 8 to the power 8 and 16. Shh. So what we need to do is think about what number, which is 2, because 2 to the power of 3 is equal to 8. and 2 to the power of 4 is equal to 16. So what we're going to do is we've got 2 to the power of 3. 3x minus 1 is equal to 2 to the power of negative 4, x plus 5. That is equal to 2 to the power of 9x minus 3. On the left-hand side is equal to 2 to the power of 9x minus 3 is equal to 2 to the power of minus 4x minus 20. So therefore 9x minus 3 is equal to minus 4x plus 20. Adding 4x to both sides, 13x is equal to 23. X is equal to 23 on 13. Did any of you?
I got 17.
Yeah, I got 17.
So
I guess you made a mistake.
Plus the 3, which makes it minus 17.
So you made a mistake.
Yeah, I did. I did make a mistake.
Yes.
Minus 20, so that's minus 20 plus 20 minus... There you go. That's what happens when I have to teach you guys for a whole double and revising. Thank you. See you next time. Bye-bye.